Hey, this is Math 6, Unit 6, Lesson 17, Two Related Quantities, Part 2. Alright, our first question here says that Lynn and Jada each walk at a steady rate from school to the library. Lynn can walk 13 miles in 5 hours, and Jada can walk 25 miles in 10 hours. They each leave school at 3 o'clock, and they walk 3¼ miles to the library. What time do they each arrive? Okay, so we're basically given some different rates here in terms of how fast they're walking from one point to another. We take a look first of all at Lynn. What do we know about Lynn? Well, we know that her name's spelled with one N, not two. That's much we know. So we know a couple things. We know that for her her distance, we know that she can do a distance of 13 miles, and she can do that in 5 hours. Okay, so we know that she can do 13 miles in 5 hours. That's a given so far for Lynn. We know that when it comes to Jada, and Jada for her distance, we know that she can do 25 miles, and her time if she does that is in 10 hours. Okay, so we know that to be the case so far. Now we want to take a look at how long it takes her. We're going to try to figure out how long it takes, or how long it takes to go 3¼ mile. So I want to turn all these distances into 1 mile segments here is the first step. So to turn them into 1 miles, that means here I'm dividing by 13. So on this side I would do 5 divided by 13 like so, 5/13. Here, to turn this into 1, I'm dividing by 25. So this becomes 10 divided by 25, 10/5, something like that, or 10/25, which I could reduce. If we chose to reduce that, we certainly could. This can become 2/5 if we want it to be that, right? Or 2/5 because 5 goes in there 2 times and 5 goes in there 5 times. Not a problem. All right. So now we know, in this case here, how long it takes to go 1 mile. It takes 5/13 of an hour to go 1 mile and 2/5 of an hour to go 1 mile for Jada as well. Okay, so we know then that that's the rate that they walk at. Okay, so in terms of an equation we're looking at here, we want to now find out how long does it take them to go 3¼ miles. How much time is that going to take? So when we continue our table, we're going to continue this down here to go 3¼ So think of this, to go from 1 to 3¼ I'm multiplying this by 3¼ which over here means I'm going to do 5/13 times 3¼ right? Multiplying it by 3¼ Now 3¼ I can rewrite this because it's going to be helpful. 4 times 3 is 12, plus 1 is 13. So I have 13/4 times 5/13. Now this one works out pretty nicely. I can just reduce the 13s and I'm left with 5/4. So to go 3¼ mile for Lynn is going to take 5/4 of an hour. Or another way of saying that, that is 5¼ hours. Sorry, 5¼ it's 1¼ hours. Boy, it's late now. 1¼ hours, and 1/4 of an hour is 15 minutes. So it's going to take her 1 hour and 15 minutes. And if you started at 3 o'clock, that would make it from 3 o'clock plus an hour 15 makes it what? It makes it 4 o'clock and 15 minutes. So for Lynn, it's going to take an hour 15, and she's there at 4:15. For Jada, okay, again, to go from 1 to 3¼ we're going to multiply this number by 3¼ So we can take our 2/5 and we can multiply it by 3¼ we said was 13/4. 13/4 like so. We can reduce a 1 and a 2, and so now we're left with 13/10. Now 13/10, that reduces down to 1 3/10 of an hour. Okay, not quite as nice. I don't know what 1 3/10 of an hour actually is, top of my head, but we know it's a full hour for sure and a little bit more. So to figure out how many minutes are in 3/10 of an hour, it gets a little more complicated. I need to say, what is 3/10 of 60 minutes? That's how many minutes this is going to be. Because this is 3/10 of an hour, and I want to know the minutes, so I can reduce 1, reduce it becomes 6. 3 times 6 is 18. So what I know is it's going to take this person, I could write down 1 3/10 here, but I know that what that actually means is it's 1 hour and 18 minutes. So when is Jada going to arrive? 4:18 is when Jada is going to arrive. All right, so that's the idea there. That's quite a long problem to figure that out, but we did it by figuring out what the rate was going to be for both of these people, and then finding out kind of the unit rate for distance for one, and then multiplying that by the new distance, right? That was the idea. So almost like, again, if you wanted to find out what the time is going to be, we multiplied it by a constant rate there. So that's what this activity is about. A lot of this today, we're going to do one long problem real quick, and then we'll jump into your homework, okay? So the next one says, Diego, Elena, and Andre participated in a walk-a-thon to raise money for cancer research. They each walked at a constant rate, but their rates were different. The table shows how far each participant walked during the walk-a-thon. So we can see we have times for 1 hour, 2 hour, some hour, and 5 hour. So let's see what we know here. Okay, so it's kind of like a puzzle. You got to figure out where you want to start and how you want to work around to figure out all the spaces. So, first of all, for Diego, in 2 hours he went 6 miles, which means if we want to go back to 1, we're going to divide this in half, right? This is divided by 2, so we're going to divide this by 2. 6 divided by 2 is 3, so we know that he walks 3 miles every hour. So 3 miles in 1 hour, 3 times 1 is 3. 3 times 2 is 6. 3 times what is 12? In this case, we'd say 3 times 4 is 12. And then down below, 3 times 5 means Diego walks 15. So we got Diego figured out, and we have this missing number there figured out as well. That number is important because it tells us what to do with the 11. So now, think about this. To go from 4 to 1, what do? We divide by 4. So it's 4 divided by 4. So we're going to take this number and we're going to divide it by 4. So we get 11 over 4. Now 11 over 4 can also be written as 2 3/4 or 2.75. Okay, that works as well. Okay, no way of writing it there. And so now we'll come back to our numbers, and we know that to go from 1 to 2, we're going to double this. So 2.75 times 2 is going to be 5.5, or 5.5. And then to go from 11 to the next one, this is just going from 4 to 5. So we're going to just basically increase by one more, rate, one more of the basic rates. So the rate here was 2.75, so we're going to add that to this. So we know that right here, we're going to get 13.75. Just adding one more of the distance walked in 1 hour to go from 4 hours to 5 hours. That's all we're doing. So then we get to Andre, and we have to do the same thing we did for Elena. We're going to have to drop back here for our unit rate by doing 17.5 divided by 5. And 17.5 divided by 5, that becomes 3, 15, 2, 5, decimal 5, 3.5 there. To go from 1 to 2, we're going to double it, so that becomes 7. To go from 7 to 4, 2 to 4 is doubling that, so 7 doubled is 14. So it's a bit of a process there, but you can figure out what all the numbers are in the squares or in the table here. So now we move on to the questions that are going to talk about this table, and it's this page and the next page, so keep this information in mind. How fast was each participant walking in miles per hour? Now, the per hour means how many miles per 1 hour. And we can look right here at this row because that gives me the miles per hour for each person. Diego, for example, is walking how many miles in 1 hour? 3 miles in 1 hour. So Diego is going 3 miles per hour. For Elena, is going, we can say 11/4 or 2.75 miles per hour, 2 3/4, however you want to think about that. And Andre is going 3.5 miles in 1 hour. How long did it take each participant to walk 1 mile? So now we're going to figure out how long does it take them to walk 1 mile. So we look at Diego and we see that he walked 3 miles in an hour, right? So Diego walked 3 miles in 1 hour. So he does 3 miles in 1 hour. And we want to know how long does it take to go, well, let's do that, yeah. we want to go, then he wants to go 3 miles. We're going to go 1 mile in how many hours is kind of what we're thinking about here. How do we figure this one out? So that's kind of what we're thinking of. So for Diego then to go and kind of solve this one out there, what ends up happening is your 3 is equal to 1 over x. And so I'm going to multiply both sides by x. So I end up with 3x equals 1. And then we divide both sides by 3. So we have x equals 1/3. So how long does it take Diego to walk 1 mile? It takes him 1/3 of an hour. Alright, let's take a look at Elena. Now Elena, we see here, what's she doing here? Well, she goes 11/4. Now notice, well, let's back up here. What is 1/3 compared to this one here? It's the reciprocal. So for Elena, we could do the same thing, but my guess is we're going to end up with the reciprocal, right? Because for Elena, we could say that she goes 11/4 of a mile in 1 hour, and she wants to know to go 1 mile, how long is that going to take? So we end up with kind of the same type of situation here, where we end up with 11/4 x, 11/4 x equals 1. Alright, and then we're going to divide by 11/4, so you end up with 1 divided by 11/4, which is 1 times 4 over 11, so x equals 4 over 11, or again, just the reciprocal of what we had up here. So she takes 4/11 of an hour to go that far. So based upon what we've seen so far, if Diego, who went 3, it takes him 1/3 of an hour to go 1 mile, and Elena, who went 11/4 in an hour, we know it's going to take her 4/11 to go that long. What do we do with Andre? Okay, so Andre, we have him here at 3.5. Now that's not a number we can find a reciprocal for, is it? Not as nice, right? So we could think of it this way. 3.5 as a fraction is 3.5. As an improper fraction, it becomes 3 times 2 is 6, plus 1 is 7/2. So for Andre, the reciprocal of 7/2 is going to be 2/7 of an hour to go 1 mile. Alright, so that's where we're at so far. Let's take a look at your next question. Next question wants us to then use this data information here to plot on the coordinate plane the progress for each person. Okay, so we're going to plot the progress for each person on this coordinate plane right there. So I'm going to read them off there. You should have them on your paper. So let's see, let's start with Diego. So Diego walked in 1 hour, Diego walked 3 miles. And there's Diego. In 2 hours, Diego walked 6. In 4 hours, Diego walked 12. And in 5 hours, Diego walked 15. So Diego, and that's his constant rate right there. You write D for Diego. For Elena, in 1 hour she went 2 3/4, so a little less there. At the 2 hour mark she went 5.5, so a little less. At the 4 hour mark she was at 11. And at the 5 hour mark she was at 13 3/4, so about here. So Elena's is just under this line right there. For Elena. Andre was a little more. He did 3.5 in the first hour. He did 7 in the second. He did 14 in the fourth. And then 17.5 in the fifth. So his line is going to be above the other one. Andre there. Those are our 3 lines. Now Diego says that D equals 3 over T represents his walk, where D is the distance and T is the time in hours. Explain why D equals 3T relates to the distance he walked and the time that it took. So we look at Diego, we can see this point right here, and we see that for every hour that he walked, he was able to go 3 miles. So what is this telling us here? The T means that we place that in the place of the hour. So each hour he walks is multiplied by 3 to give the distance he walked. So if he went 1 mile, 1 times 3 is 3. If he went 2, 2 times 3 is 6. So that becomes how we relate to what he's doing there. Okay? So that's what we have there based upon, again, the number 1. So equations for Elena and Andre. So Elena and Andre, same idea. We have D equals a rate times a time, a rate times a time. Well, where do we get this rate from for Diego? Where do we see 3 at? Well, we see it right here for how far he walked 1 mile. So for Elena, her rate's going to be 11/4. And for Andre, his rate will be 3.5 or 3.5. Same idea. So those are the rates we would use to make the equations for Elena and for Andre. Okay, does that make sense there? And again, you can make them as decimals. It doesn't make a big difference. Okay, so those are our 3 equations. D equals 3t. All right, now the question 6 says to use the equations you wrote to predict how far each person walked if they went 8 hours. All right, so let's do each one. So Diego is doing what? Diego is D equals 3 times t. Elena was D equals 11/4 times t. And Andre was D equals, and we had 3.5 times t. So what they're asking to do is to put the 8 in the place of each t. So 3 times 8 is 24 for Diego. 11/4 times 8, we reduce that. So we end up 11 times 2, which is 22. And then here we have 3.5 times 8. And 3.5 times 8 is 28. So how far do they go in 8 hours? Diego goes 24 miles. Elena 22 miles. And Andre 28 miles. So Andre's definitely traveling the fastest there. In these equations, is there a dependent and independent variable? Yes. The dependent one for each one that I wrote here is going to be the distance. The distance they each travel, which is these numbers here, in the end, depends upon the independent, which is the time in which we're trying to time them for traveling. That's how we work that out there. Okay, so in summary, equations are very useful for solving problems with constant speeds. All right, great. And they give you an example here. A boat traveling at a constant speed of 25 miles per hour. How far can it go in 3.25 hours? And then how long does it take for it to go 60 miles per hour? So you can solve both these problems by using this constant rate right there. And here we can set up 2 different equations. We can say if we want to find out the distance that it traveled, we make time the independent variable and we multiply it there. If we want to find out how long it takes, the time, then we make that the dependent variable and we make the distance the independent variable. So you can set the same equation up, or different equations up, using the same kind of formula there. So a D and a T and the 25 depends on what we're going to do with it there. You plug in the numbers that you got in order to solve it and get the solution that you need. Okay, so the equation helps us get that, and then the other thing that's there, which I forgot to show last time, I forgot about that, sorry, is you can take those same points that you get in the equation and you can plot them on a coordinate grid and see a pattern of how this works over time. And you can see here, there's the pattern, it's going this way, and this one goes this way. Depending on which one you make as your dependent and independent, it's going to affect things there a little bit. Okay, so that's it for today. We're going to pause there and let you work on your homework. We'll come back and check it together in just a moment. All right, homework time, lesson 17. A car is traveling down a road at a constant speed of 50 miles per hour. So we're going 50 miles in 1 hour. All right, so complete the table with the amounts of time it takes the car to travel, certain distances, or the distances traveled. Okay, well, we know when it goes 50 miles that happens in 1 hour. So if you think about what our constant is, that's the value that goes here, right? 1 times that constant is going to give you the distance. That's the constant. So here we do t times 50, which becomes 50t. and we do 2 times 50, which is 100 miles, and we do 1.5 times 50, which becomes 75. So it's pretty easy to go across this way. When I want to go the other way, then remember, I'm going to multiply it by the reciprocal, 1 over 50. So what is 300 times 1 over 50? Well, the zeros cancel, so we have 30 divided by 5, which is 6. And this becomes times 1 over 50, or 150d. Alright, so that's how we get there, basically using our rate and then doing the reciprocal to find out what the time would be there. So can we write an equation that represents the distance traveled by the car d for the amount of time? Yes. So the distance traveled is what we're looking for. D is going to equal what? What is the d, the distance, going to equal? The distance equals 50 every single time, that's our constant rate, times the distance, or times the time, sorry, t. In your equation, what is the dependent and what's the independent? Now our dependent here was the distance. That depended upon what? On the time we allowed the car to travel. So that's our dependent and our independent variables there. Number 2. This graph represents the amount of time in hours it takes a ship to travel various distances in miles. Write the coordinates of one point on the graph. What does the point represent? So I'm going to pick this point right here. This point is what? It's 50, comma 2. Because here's the 50, here's the 2, 50, comma 2. So what does that represent? Well, it tells me when the boat travels, or to travel 50 miles takes 2 hours. I could also say after 2 hours a boat will have traveled 50 miles. Depending on how you want to read that graph, that is what that is saying there. Now the next question, B, wants to know what is the speed of the ship, in miles per hour. So we're looking for that 1 hour mark. So how many miles does it go in 1 hour? Well, the 1 is here. So look at the 1, we have a point, and we can see that it goes 25 miles in 1 hour. So this ship is going 25 miles per hour. Write an equation that relates the time t it takes to travel a given distance d. Okay, so what we know so far is we know that it was taking us, in our case here, the distance that it traveled, or the time that it traveled, was equal to, so to find the time, we did 25 divided by the distance, okay? 25 divided by whatever the distance, d, okay? So that's going to be our thing here. We have 25 over d. Did not explain that very well, sorry. Let's do it this way. The distance traveled, the distance is always going to be 25 times the time. So then to get the t by itself, get the t by itself, we're just dividing everything by 25. So both of these equations would work to be able to help you figure out the time or distance traveled by the ship, depending on which one you want to call your independent, which one you want to call your dependent variables. Alright, number 3, we're going to find a solution here to each equation from the list of numbers. Alright, so 2 times what gets you to 8? Well, let's say 2 times 2 is 4, another 2 is 6, number 2 is 8, so that's going to take 3 of those, so x here is going to equal 3. Check. To get 2 to equal 2, this x needs to be just simply a 1. Check. What number squared gets you to 100? We would say 10 squared, 10 times 10 gets you to 100. So 10. Over here, what square gets you to 1 over 100? This is going to be the inverse. This is going to be a reciprocal. 1/10 times 1/10. So we're looking at squaring the number 1/10. There. How do we get to 7? What number to the first power gets you 7? Just simply 7. Over here we have 2x times 2, or 2 to the x power times 2 to the third power gets you 2 to the 7th power. So we want a total of 7 2's. 1, 2, 3, 4, 5, 6, 7 on this side. We already have 3. Those 3 go with 2 to the third. So what is this one going to be? That's going to be 2 to the what power? 1, 2, 3, 4. So x is going to be equal to 4. And this one over here, we want to get 2/5 altogether. So I want some 2's on the top. But on the bottom, I already have 2 times 2 times 2. I still want to have 5 left over. But if I just put 5 up here, these ones cancel out, don't they? So that only leaves me with 2 up there. That's not enough to leave 5. I want to leave 5. So if these cancel, I need to have 1, 2, 3, 4, 5. So in total, how many to start on top? 1, 2, 3, 4, 5, 6, 7, 8. I need to have 8 on top. This should be 2 to the 8th over 2/3. So we'd say 8 for that one right there. Alright, and finally, select all the expressions that are equivalent to here. This is a great one because you can factor out a 5 from each of those. I can also factor out an x from each of them. I could factor out a 5x. If I factor out a 5, I would be left with here x plus 30 divided by 5 is 6x, and 15 divided by 5 is 3. So we'll be left with something looking like that. If I factor an x out of everything, I would just have a 5 plus the 30 minus the 15. Okay. Or if I factored the 5x out of the whole thing, I'd be left here with a 1 plus, in this case here, 6, and the x is already out, and then we'd be minus the 3, something along those lines. So that works as well. So let's see what I have for choices. I have 5 times x plus 6x minus 3x, so that's that one. Great. Here's 5 plus 30 minus 15 times x. There's that one. That's great. X times 5 plus 30x. I can't multiply by another x. It's not going to work, so no. Here's 5x factored out times 1 plus 6 minus 3. Yes. This is a 5 factored out by itself, which we did up here before, and they did x plus 30. It should be plus 6 and 3, so these are wrong. Not going to work. Alright, that's it for today. Have a great day, and we will see you next time.